Okay, let's get started. So, what we're talking about is how to estimate adding and subtracting fractions that have unlike denominators. So, let's get started with the idea of what a benchmark fraction is. When we talk about a benchmark fraction, we're thinking about benchmarks like 0, 1/2, and 1, respectively. So when we talk about a benchmark, what we're going to do is decide whether a fraction is close to 0, close to 1/2, or close to 1. Let's take a look at an example. A fraction that is close to 0, as an example, would be 1/3. We know that this 1/3 is close to 0 because the numerator 1 and the denominator 3, 1 is much closer to 0 than it is to 3. So we can think about it as estimating as a 0. For 1/2, we can look at something like 3/7. We can look at the numerator and the denominator and compare them. 3 is about halfway between 0 and 7. So since it's about halfway, it's close to halfway, we can say that it's about 1/2 and use 1/2 as a benchmark. Lastly, we have 1. Some fractions, like 4/5, are closest to 1. That's because when we compare the numerator with the denominator, 4 compared to 5, 4 is closest to 5 when you think about between 0 and 5. 4 is very close to 5, so when we estimate, it's close to 1 whole. Now let's use this idea of 0, half, and 1 as benchmarks to add and subtract fractions using estimation. Let's take a look at a problem like this one. 1/6 plus 3/8. The first thing that I'm going to do is rewrite my problem in vertical format. That makes it easier to work with. So I'm going to write it as 1/6 plus 3/8. And I'll draw a sum line there. So now that you can see that when we have this here in vertical form, it's the same as this, it's just in a different format. So what I'm going to do is eliminate this here. I don't want to use this anymore, so I just get rid of it. And now I can take this and move it into a more prime position to work on. So now I'm looking at 1/6 plus 3/8 again, but it's in vertical form. What I'm going to do is use those benchmarks I talked about to rewrite and estimate. So I'm going to write my estimate in this section. I look at 1/6 and I say to myself, the numerator 1 is not very close to the denominator 6. In fact, it's close to 0. So instead of looking at it as 1/6, I'm going to look at it as 0 or nothing. Then when I look at the next one, 3/8, first I'm going to put my addition sign here. And now I look at 3/8, and I want to think about numerator 3 and the denominator 8. 3 is kind of in between 0 and 8. So since it's about halfway, I'm going to think about it as 1/2. And when I do my sum now, 0 plus 1/2, I can say that 1/2 is an estimate for 1/6 plus 3/8. It should come out to about half. And that's the answer I have. 1/6 plus 3/8 is about 1/2. We can use that later to compare with when we actually solve problems like this one to see if our answer is close to 1/2. Let's do another problem. Let's take a look at this one. 9/10 plus 5 eighths. Again, I'm going to take this horizontal one and make it vertical so that we can work with it better. I take 9/10 plus 5/8, and I write a sum line. I'm going to get rid of this one up here again, because all I did was take what is there and reformat it. It's the same problem. So for easiness, we're going to get rid of this and move our other piece up higher so that we can work with it and see it better. Now we're ready to estimate. We take a look at the first one, 9/10. The numerator 9 and the denominator 10. Compare them. 9 is very close to 10. Much closer to 10 than it is to halfway between 0 and 10. So we can rewrite it as 1. 1 whole. 9/10 is very close to 1 whole. Now we look at the next one. I put my addition sign so that I don't forget to do it later, and I look at 5/8. Compare the numerator 5 with the denominator 8. 5 is almost halfway to 8. Between 0 and 8, 5 is kind of in the middle. So we can say that 5/8 is close to 1/2. And I rewrite my sum line. Now, looking at that, 1 plus 1/2 equals a half in the fractional place value and 1 in the ones place. So 9/10 plus 5/8 is about 1 1/2. Let's try one more. So now we're going to look at 1 8/9 plus 4 4/5. So now that we're looking at something that's a mixed number, it's a little bit different, but it's not much different at all. You'll see very quickly. Like I always do, the first thing I'm going to do is set it up vertically. So I'm going to take 1 8/9 plus 4 4/5. And I draw my sum line. I don't need this anymore, so I'm going to eliminate it because it's the same problem, it's just set up differently. And now I'm going to move this up here. Now I'm ready to estimate. Let's take a look at 1 8/9. When we're estimating fractions, we don't estimate the whole number, it's already there. So what we estimate is a fraction. So let's take a look and compare 8 and 9. 8/9. The 8 is very close to 9. It's much closer than halfway or 0. So 8/9, it can be estimated to 1. So what I'm really looking at is the 1 I already have and the fraction now estimated to be 1. I'm looking at instead a 1 here, like this. So when I think about it, I have 1 and another 1, and means add, so I'm going to do 2 as my estimate. 1 plus the fractional part that's about 1 is about 2. Now I move to my next one. Plus, so that I don't forget it later, 4 4/5. Again, I'm not worried about estimating this piece, it's a whole number. I'm estimating the fraction. 4/5. The numerator 4 is very close to the denominator 5, much closer than it is to 0 or halfway. So I take my 4/5 and I'm going to do the same thing. Instead of looking at it as 4/5, I'm going to look at it as 1. So now I'm ready with 4 that I already have, and the 1 that is an estimate is more like 5. and I write my sum line. So now I have an estimate of 2 plus 5, and estimated 2 plus 5 equals 7. So our answer is about 7. Now let's try some with subtraction. I think you're ready. Now we have subtraction. 4/5 minus 3/8. If you recall with adding and subtracting fractions with like denominators, then when the denominator is the same, that it doesn't change. But when they're unlike, you can see that 5 is less than 8. And it seems like when you subtract, you cannot take away 8 from 5. But if we apply this idea that the denominators need to be the same when we add and subtract, not when we're estimating, when we actually do the computation, remember, our denominator isn't something that we think about. So the fact that right now 5 is less than 8, that's almost meaningless in this situation. So remember, when we estimate and we make it a new benchmark number for our estimation, we won't be working with these denominators. So let's get to it. 4/5 minus 3/8 can be rewritten in vertical form as 4/5 minus 3/8. Now that I have that, I'm going to get rid of this. It's the same problem as always, and I'm going to move this one in a much more prime position for working. And I forgot to put my difference line. Don't forget that. Now, 4/5 minus 3/8. Let's start estimating. 4/5. Compare them. 4 is very close to 5. So we can estimate 4/5 as 1. Now we estimate the next one. I'm going to put my subtraction symbol so that I don't forget it later. 3/8. 3 is about halfway to 8. Between 0 and 8, 3 is about halfway. So I can think of this as 1/2. So as you can see, we're not worried about the denominators right now. We're just estimating. We're not worried about them. So now I can do the operation. 1/2 and no other fraction is still 1/2. Because I'm taking away 1/2 from 1. I'm not actually taking it away from nothing. I'm taking it away from a regrouped 2 over 2, which is the same as 1. 2 minus 1 is 1. So my answer is about 1/2. Let's take a look at another one. 5/11 minus 1/5. I can rewrite this number sentence in vertical form for easier use. 5/11 minus 1/5. Subtraction line, or difference line. Now I don't need this anymore, so I'm going to delete it, and I'm going to move this into a better position for working. Now I'm ready to estimate. 5/11. Compare 5 to 11. Between 0 and 11, 5 is close to halfway. It's very close, in fact. So I can think about 5/11 as 1/2 instead. Now I'm ready for the next one. I put my subtraction line so I don't forget to do it later. And I think about the comparison between 1 and 5. 1 is very close to 0 when compared to 5. Between 0 and 5, 1 is very close to 0. So instead of thinking about it as 1/5, I can estimate and think about it as 0. And now I write my difference line, and as you already know, anything minus 0 is itself. So 1/2 minus 0 is 1/2. So when I think about this, I can say that 5/11 minus 1/5 is about 1/2. Very cool. Let's do one more just to be sure. Let's use a mixed number this time. Now we're going to do 3 and 5/12 minus 3 and 1/10. I want to set this up vertically for easier use. It's the same, but it makes it easier to do the work. 3 and 5/12 minus 3 and 1/10. Difference line. Now that I've got it, I'm ready to get rid of this and move this into a better position so I can work on it. Now let's estimate. 3 and 5/12. Remember, our 3 is going to not be affected by our estimation here because the whole number remains. It's the fraction that we're estimating. So let's begin. 5/12. Compare it. Between 0 and 12, where is 5? 5 is about halfway. 6 would be exactly halfway, and 5 is very close to being 6. So when we estimate, we can think about this instead as 1/2. So when we rewrite it, we have 3 and 1/2. Now I'm ready for my next one. I'm going to put my minus sign so that I don't forget to do it. And now I look at an estimation for 3 and 1/10. The whole number will remain, and I'm estimating the fraction. 1/10. Compare the 1 to the 10. Between 0 and 10, 1 is very close to 0. In fact, it's almost 0. So, I can think about this 1/10 instead as 0. So, when I rewrite it, I'm looking at 3 and a 0. So 3 and 0 would just be 3. And no fraction. I write my difference line. Now, just like you would with any subtraction problem, we move from right to left by place value. We start with the fraction. 1/2 minus nothing would be 1/2. Then we move to the next place value, which is the ones place. 3 minus 3 is 0. For me, personally, when I have a 0 that represents the whole number, you can write the 0, but for me, I like to eliminate the 0. But we write it there so that we know we did the operation, and then if in our nice, neat, clean answer, we write just the 1/2. But since we estimated, it's not 1/2. That's not the answer. The answer is about 1/2. Great job. Now you're ready to try some on your own.